Hello everyone. Welcome all of you for the fifth video lecture on the topic Autodesk Robot Analysis software. In the previous four videos, we discussed about the continuous beam and the frame. Here, I am discussing about the truss, experiment number 5, analysis of truss. Our aim is to analyze the truss by using the software Autodesk Robot Structure Analysis. So here we are having the truss with so many members A, B, B, C, C, D, D, E, and A, F, F, G, G, H, H, E, okay, and all the vertical members here, and it is subjected to point loads 1 kilonewton, 2 kilonewton at the joints, okay, and the angle is given to you, it is 30 degree and 30 degree here, and the lengths are 2 meter, okay. So we need to model this one, and after modeling and analysis, the results finally we are getting the member forces. So for the truss, we need to calculate the member forces in each member. So for that, I will move on to the software. We are in the front page of our software. To create a new project, click on New. So in this window, previously we have discussed about the continuous beam and frame. We have selected this frame 2D design, but now we are going to discuss about the truss. For that, select this truss 2D design. Okay, so this figure, click on this figure. We got the main page. It is loading. Yeah, we got the page. Now just verify the units. Go for the tools, units and formats. Here the dimension in meters, section dimension mm, forces kilonewton and moment in kilonewton meter. Press OK. Then I need to set the ruler for that view, grid, then grid step definition. So I can set it for 1 meter and 1 meter interval. Okay, apply and close. So zoom it. Yeah. Then go for the view, grid, turn off this dots. Okay, it is not required. Now I need to define the axis. For that geometry axis definition, first we need to see the figure, the truss. Observe here, in this truss the x values are given 0, 2, 2, 2 meter and 2 meter. Is it right? But along the z axis it is 0. I need to find this distance, that FB. Okay, I need a reference line here, and also I need a reference line at this point also, that GC. Okay, so 0 and this level and this level. So for that I need to consider the right angle triangle of this one. Okay, I will show in the next figure slide. Okay, I'm sorry here, I need to find this height. So I will take this CGE triangle, CGE, and I name this CG as H1. Okay, and the length is given to you as 4 meter and the angle is 30 degree. This bigger triangle, right angle triangle. Okay, so in this right angle triangle, I have the 30 degree, and I need to find this H1. So I will apply the tan 30 degree. Tan 30 degree is equal to opposite by adjacent. Opposite is H1 and adjacent is 4 meter. I got H1 as 2.31 meter after calculation. Same thing, I need to find this level also. For this, I will take the smaller triangle DHE. So I have taken H2. H2 nothing but HD and FB. Both are same, the same level only. So same angle, the 30 degree. If I consider that, so I got H2 as 1.15, 2.31 and 1.15. These are the two values. So now I will move on to that screen. Yeah, in that X value, it is 0, add, then 2, add, then plus 2 means 4, add, then 6, add, then 8, add. Okay, see here 0, 2, 4, 6, 8. So then 0, 2, 4, 6, 8. The z axis, first will be z, 0, then 2.31, it is 2.31 we have calculated, add, then another value is 1.15. So another one value is 1.15, add 0, 1.15 and 2.31. After this, apply and close. Yeah, we got the reference axis for that. Now I need to define it, the property of the member. Now I will move on to the geometry, bars only. Okay, select this bars. So previously we have taken the bar type as RC beam. Okay, it is a concrete element for the analysis purpose. So here the truss nothing but it is not made up of concrete, it is made up of steel elements. It may be T section or L section or I section. Okay, so we need to find the member forces in that section. So for that, select the bar type as simple bar only by default, and section it is already given some section, don't worry about that section, just provide the same material for this truss. I start from here, just see this is one reference axis. Okay, start from here. Okay, this will be my first point, first one, select from here to here, then here to here, same thing here to here, this point to this point, then same thing, join all the points. Okay, these are the members and in my truss. Then we are having a member here also like this, here also the entire, and also the member, and I have some members. Okay, diagonal members. So here I will provide some diagonal members also. Yeah, after this close, just see this will be my truss having the length like this. Okay, then I need to provide the supports. Here it is inch and here it is roller. So go for the geometry, then supports, and take the pin. It pin is nothing but inch, so place it here. Go for the roller, place it here, the roller, close it. So we got this. Then I need to apply the loads. For application of the load, go for the loads, then load type. Here we can provide dead load. So for that, by default it is there in the dead, add it. It is added. Then nature, you can change that one to live, add it. Okay, I applied that one also, then close it. Then go for the loads, load definition. Previously we have taken the bar loads because it is a continuous beam and frame, but it is a truss. We need to apply the loads on the joints only. For that, select the node only. Okay, node, in that node force, nodal force, select this one. Here it is subjected to -1, -2, -2, -2, -1. So here it is going downward, it is going in the z direction, vertical, that's why it is in z value, minus because going downward, -1, add it. So place it at this point and at this point also. Then same on the nodal force. So the value is now -2, add it. So it is acting at this joint, second, 3. So these are the points. Apply and close. So to see the loads, right click, display, loads, load symbol, load value, apply and OK. Now it is visible. Okay, then I need to analyze the entire structure, analyze to analyze the truss. Go for the analysis, calculations. So it is analyzing, it is analyzed. To see the results, go for the results, same. Okay, diagram for bars. In that diagram for bars, I need the reactions, select on the reactions, select all, and also, okay, don't select this. Okay, it is having in support also, right? So fx and fz, diagram for linear support, description also I need, apply. Okay, and close this one. You can drag it down, just see fx is 0, no horizontal force. Okay, the value of fz is 4 4. Okay, uh, these are the values acting on this. This fz is -1, this one is a load. Okay, for this point, and this Fz indicates the reaction of that one. Okay, because it is acting at the same point, that's why it is showing two values. -1 is applied load, -1 is applied load. This 4 and 4 are the reactions of that supports. No horizontal force, no Fx. Okay, it is 0. Now I need to take the printout and I need to see the picture clearly. For that, go for view, display. You can increase this size to 40 if you want. Apply and OK. Okay, it is now visible clearly. Then file, screen capture. Then name it as truss 1. Okay. Then finally I got the reactions. Then final result is the member forces. Go for the results, diagram for bars. First remove these reactions. Okay, select these reactions, select on none. I don't want the description diagram for parts. Apply and close. And I don't want the loads also. I don't want this load also. So go for the right click on the main screen, display, then loads, and select these load symbols and load value. Apply and OK. It is removed. I need the member forces. To see the member forces, go for the loads, sorry, results, diagram for bars. Then in the NTM, Fx force, this indicates the member forces. Okay, so apply it, but the values are not visible. So in this parameters, select label, differentiated, fixed, fill, and also the values, all values I need. Apply. Yeah, so we can see the things. Okay, and close. Apply and close. Yeah, here we can see the truss with the member forces. This one is having 6 kilonewton force. Here it is 4, 6, and here it is this member and this member. This vertical members having not having the forces. It is 0 members. This member and this member, and it is differentiating the positive and negative value. Okay, positive value is in blue color, and the negative value is in some other color, yellow color, right? So this indicates uh, these blue members subjected to compression. The positive value indicates the compression and the negative value indicates the tension. This yellow color members are subjected to tensile forces, and these blue color forces members subjected to compression. Okay, positive nothing but compression and negative nothing but tension. So here the decrease in the length, here increase in the length. Okay, to take the snap of this one, go for the file, screen capture. You can name it as member forces. After this, press OK. Then file, page setup, header and footer, header in that edit. You can name this one as truss 1. Then close this, yes. Then press OK. Then file, then print out composition. So I need these two figures all. Then go for the preview. We got the preview of this one in a single page. So to edit that one, go for the edit. So I got the symbol, click on this screen. So here I'm zooming it and placing in the middle. Return to preview. Same thing for this member forces. Zoom it, return to page. Or if you want to change the color, you can change it. Okay, on that setting only. Now I will move on to the print. Then print to PDF. Yes, okay. Okay, I will save this one in the desktop only, and I name it as Tress 1. Tress 1, save. It is saving the single page of the. Then I will close this one, and I will save this file also. So for the save in the experiment folder, I save it as Tress 1. Okay, save. Okay, after this, okay, it is saving the file. Okay, after this, minimize this window also. Okay, it is here in the desktop. Press 1. If I double click on that, you can see the results of that. So you can see the member forces also. Positive nothing but compression, negative nothing but tension, and no force, nothing but no figure here is 0. You just see 0 member. These two vertical members are 0 members. It is not subjected to compression or tension, but this is compression and this one is tension. So this will be the end of the video. Thank you one and all.